I'm going to be talking about using Apache Kafka with Ruby. There's sort of a background on why I'm talking about that and why I'm even involved in this stuff. So I've been working at Zendesk for more than 5 years now. And when I started, we were just Zendesk, the customer support software company. And now we have a bunch of different products. We've also gone from being a dozen or two developers to being hundreds. I don't even know how many people there are. And we have developers in 6 countries. So it's been a massive change from when I started, and the challenges we're seeing are very different. So what we learned, and I think most companies that grow learn this, that communication is hard. And the more people you add in, and especially the more offices you add in, the harder communication becomes. And we're struggling with achieving some of the goals that we set out to do. So we have a bunch of different products now, but of course, these should all integrate really well. We're still one company, and we're trying to make like one Zendesk experience. But it's difficult when these products are designed by different teams, using different languages, using different methodologies, and people have different perspectives on how to build things. A lot of people just said, well, you know, if you need these products to cooperate, just pull out shared services. You know, that's a catch-all solution, microservices, boom, problem solved. And it turns out not so much. The same issues that cause communication to be hard, different backgrounds, different perspectives, different needs in terms of throughput, reliability, how you want to do stuff, impact services. So all the consumers of a service would disagree on how that service should be constructed and how it should be used. So it's not a panacea, unfortunately. So a few years ago, we agreed to start using Kafka to solve some of these problems. And why and how we did that is something I'm going to talk about in this presentation. So I was actually opposed to adopting Kafka, which is ironic since I'm now maintaining a Kafka client library. But I was opposed to it because there was no actually maintained Ruby client. There was an unmaintained Ruby client that hadn't really seen an update in several years, and that I was worried about using in production at our scale. But we decided to use Kafka anyway for a range of reasons. And then we're sort of just like left there, trying to figure out how to proceed. And initially, we just had to use the gem that wasn't maintained. But we ran into a bunch of issues. And after one really bad bug hit us, and we had downtime on the product that I'm working on, I just became angry. And in a fit of rage that lasted 2 weeks, I wrote the initial Ruby Kafka client library. And since then, I've been stuck maintaining it. So don't write code in anger. So that's sort of the background on why I'm here and my involvement with Kafka. Kafka is going through a lot of development these days. A lot of stuff is happening. I'm just trying to follow and implement stuff in the client library as fast as I can, but it's a big challenge. So if anyone after hearing this is interested, you know, it would be lovely to get some help. So there are 3 parts to this talk. First off is what is Kafka? And then why you would want to use Kafka, what benefits do you get from it? And finally is just briefly how you can actually do this from Ruby. I'm not going to go too deep on that. There's great documentation, if I have to say so myself. So it's very easy to get set up and started, actually. So what is Kafka? First off, who has heard about Apache Kafka? Well, that's actually a lot of people. Has anyone used it in production? A few, OK. So Kafka is 2 things mainly. It's a publish, subscribe, broker, first thing. So who knows about the pub/sub pattern? That's also a lot of people. OK. So it's something that people are somewhat familiar with. Using publish, subscribe, many processes or objects or whatever would produce or publish to some topic. You would write messages to a topic, and then you would have some other processes consuming or subscribing to these messages. This is many-to-many communication. This is different from normal operations where you say, okay, you take this message. Rather, you send it to this topic, and then something happens. You don't care. It gets sent to many other systems. You don't know which. Sort of looks like this. So the main thing is that this is different from a system such as Rescue or other job processing systems where a given consumer gets a subset of the messages. Here, every consumer gets all the messages. So you send out copies to each consumer, basically. And now you may be thinking, well, that sounds great. I have a use case for that. But I'm writing a lot of messages. I'm recording. I want to send a message every time there's a page view in my popular Snapchat clone or something. How can I scale that out if a single process needs to be able to handle all the messages? That's where Kafka has a nice answer. You can use something called consumer groups. So basically, you can think of consumer group as one of the consumers in the previous slide. But instead of it being a single process, it is split into a bunch of processes that collaborate on handling all the incoming messages. So you'll still handle all the messages, but each member of the group will handle just a subset. And there's internal coordination on which members should handle which message. Also, and this is really nice, in Kafka there's a delivery guarantee of at least once, meaning that if a message is successfully written to Kafka, you can be sure that a producer consumer will actually consume it at least once. And this is also true for consumer groups. And that's a very nice guarantee to have. You may consume it more than once, though. So you have to think about that. So that's PubSub. So I think it would probably be best because there is a bunch of different topics here. So if you have a question, just raise your hand or make a sound or something, and I can sort of elaborate on that. I think I have enough time to cover questions, and also have some time at the end. So you can also wait if you want to. Any questions about like PubSub and how you do that? Okay. Don't hesitate to stop. Kafka is not just a PubSub system, it's also a persistent message log. Basically, sort of a database for ordered messages. What this means is that all messages are persisted to disk. This is very different from most other PubSub systems that work in memory, something like RabbitMQ. By default, it keeps all messages in memory. It receives a message, stores it in a buffer, then it copies it out to each subscriber, and then it removes it. You can enable durability, which means that message is also written to disk. But that has a high cost in terms of how much throughput you then can sustain. And there's also a limit to how many messages you can actually durably write. So that's actually a big problem. Kafka works in a very different way. All messages are persisted to disk. There is no option for turning this off. All messages are also replicated. This can be turned off. But by default, you will want to replicate each message to several nodes in the Kafka cluster. One nice thing about this is that a consumer can go back in time. So you can save messages for like 30 days. You can store messages indefinitely. And a consumer can go and say, hey, I actually want to start reading messages from the very start of time, and then read everything in. Something that's really nice about that is that you can implement search indexer really easily using this. If you have a web application that creates articles or something, you can simply write each article into Kafka, store them forever there, and then you can have a search indexer that starts reading from the beginning of time and writes to Elasticsearch or something. If you then make a change of how you want to index stuff, you can restart that process from the beginning of time again, read through everything, fill up Elasticsearch, and when you hit the end of the topic, it'll just sit around and wait for new messages to arrive. So there's no difference between the backfill part of indexing and the wait for new stuff to happen part. It's just one process. So internally, the way this works is that each topic actually consists of one or more independent partitions, and they're actually the unit that you deal with in Kafka. So Kafka doesn't abstract a lot of things from you. You sort of have to know some of the innards in order to be able to operate it effectively. And partitions is a primary concept. So a partition is a strictly ordered set of messages. Each message has a well-known offset that is monotonically increasing in the partition. But you can have many partitions in one topic. Producers write directly to partitions, meaning that the client needs to know which partitions are there and how to distribute messages. And yeah, I've done all that work, so you don't have to. And consumer group members use partitions as the way to distribute messages. So basically, the members of a group agree on which member should own which partitions, and then that member will just read from those partitions. Now, this is really powerful because it means that the content of a topic can be distributed over your entire cluster. So if you have an 8-node cluster and you have, say, 16 partitions in your topic, you could have 2 partitions on each node, meaning that you get a great distribution over your cluster. And that can sustain a lot of throughput if you look at the entire topic. There's also a bit of magic in choosing the right number of partitions. So it's not all easy. You have to think about some things up front. OK, so that's basically what Kafka is. It's a pub/sub system. It's a distributed persistent message log that is partitioned, and you can retain messages. You can do pub/sub stuff. So any questions on that? OK. Next up is why you'd want to use Kafka. So this is, Kafka's neat and all, and it can sustain massive throughput, which is one of the reasons why we chose it. But what problems does it solve for you? There are 3 main problems that it solves, I think. One is coupling between different components. When you have a Kafka producer, there's no way of knowing who will end up reading the topic that you produce to. And that's a huge benefit. You don't need to care. You just write the data that you want to provide to the system. You write it into Kafka, and then you move on. So you can add a new consumer without actually touching a producer. Now imagine if we didn't have Kafka or another pub/sub system. If you have some services, let's say service B wants to be notified whenever something happens in service A. Well, service A has to call, let's say you have a REST HTTP setup. So it has to call an API endpoint in B whenever that happens and tell B about it explicitly. It has to know about B. And now you add C, and C also wants to know whenever something happens in A. So now A needs to call out to B, and then needs to call out to C. You can imagine what would happen if we add D. So every time you make a change in one part of the system, you also need to update the places that produce the data. And that adds coupling and complexity. And if you have different teams on different continents working on those different services, that could become an issue, especially if B and C wants the data in completely different formats, or one wants it in bulk every 10 minutes, and the other one them as soon as possible. It can become tedious. That's where Kafka can help you by decoupling the production of data from the consumption of it. This is how a typical microservice architecture would look like. You have a bunch of point-to-point communication links. And if you go the Kafka route or a pub/sub route, communication happens through a centralized, highly available broker system. So related to coupling is reliability. First of all, Kafka is highly available. Each partition has a primary node responsible for accepting writes. And if you have replication in place, there's automatic failovers to replicas. But what it really means is you can have a reliable system. Imagine in the previous example with A, B, and C. What would happen if someone did a bad deploy of B, or some network link crashed, or the nodes running B crashed, something like that? B is down. Well, what would happen to A? If A is a business critical application, like typically you just assume that that wouldn't happen, and A would also crash. And maybe that would trigger a cascade of failures across your product, and customers would be unhappy. But if you have thought about it, what can you really do? Like you can say, if there is an error, just don't send data to B. Or have a timeout in place. You also need a timeout in place. What if B takes a minute to respond, right? You would tie up all your A processes just waiting for B to respond. I've seen that in production. There's a bunch of stuff you have to worry about when you have this point-to-point communication. With Kafka, you don't have to care about whether or not B is running. You just write the message into Kafka, and then you continue with the business. The power of this is if B is down, but B is a Kafka consumer, when it starts back up again, it knows where it left off. Kafka can resume it from the position it reached in the topics, so there's no data loss. So you both get a highly available system, and you avoid data loss. And that's really powerful, and one of the primary reasons why I like Kafka as a system. There's also the case of data reuse. One of the reasons we wanted to set up PubSub and Kafka is that we have a bunch of orthogonal concerns to each of our products. We want to have a unified analytics product that can pull in data from all the different products we have. We have audit logging. We have a bunch of different concerns that span all our products, but we don't want to have to call out to those shared services from each and every product in the same way and coordinate all that. We also don't necessarily want our products to even know that security logging is happening or be responsible for it. Instead, what we're doing is we're writing data to Kafka, and then we would have, say, a security auditing app sit there and gobble up all the data and store whatever it needs to store in order to produce an audit log. And the same for analytics. We can simply copy stuff into the analytics system, the data warehouse, whatever we need to, without involving each application in the specifics. Okay, any questions? No questions? Okay. So how would you actually go about using Kafka from Ruby? Well, that's where I wrote the gem in my fit of rage. You simply install it, and then you point it to at least one broker. It auto-discovers the entire cluster, and it should just work. So a very typical use case I see in Rails is that you want to produce messages describing events in your system, page views, or purchases, searches, stuff like that. It was one of the first use cases we ran into. And for that, I would recommend using what's called an async producer. So this is sort of the most hands-off approach you can take. An async producer is an object with a background thread. You produce messages, and it buffers those messages, and at a fixed interval, the default is 10 seconds, it tries to deliver the messages to Kafka. And if it fails, we'll try again in another 10 seconds. So it means that it does a best effort attempt to get your messages there. It doesn't actually guarantee that the messages make it. And there's no way to guarantee that. If your node crashes, it'll lose whatever messages are buffered but not yet sent. But it does a best case, best effort attempt. And the reason you may want to do that is that you don't necessarily want a hard dependency on Kafka. Like Kafka is highly available, but there's still stuff that can go wrong. And if you have a hard dependency on Kafka being up, then you may have two systems like MySQL or Postgres or whatever, and Kafka, or maybe also Redis. And the more you add, the higher the probability that you're going to have one of them being down and you're going to not be available for your customers. So I recommend doing this. It handles most error conditions. If you have a system where you need to guarantee that now Kafka has received this message, then you can use a normal synchronous producer. For instance, if you have an API endpoint that accepts events from some JavaScript, and it needs to write that to Kafka, you may want to guarantee the client that the event has been processed and it has arrived in Kafka. And you can do that by calling deliver messages yourself, but then you have to deal with all sorts of exceptions that can arise, weird timeouts, stuff like that, and implement your own retry behavior or just like drop shit. That's, I don't recommend it unless you really need to. Consuming messages is really easy. If you looked at the Java API for this, I mean, the official version is Java. You can imagine it's less concise. Let's just say that. So it's really easy. So this basically just starts reading messages. And you can ask it to read from the very start of a topic or from the end of a topic, in which case it'll just sit there and wait for new messages to arrive. And it'll just block and write every message to stand it out. Oh, sorry. The question was, what's the default? I believe the default is reading from the beginning, but it's very easy to change. And it's still sort of, it's not 1.0 yet, so those things may change. It's better to be explicit about it in your usage. I didn't include all the options here, but you can be very specific about stuff. But yeah, oftentimes, yeah, it's a good idea just read everything if you want to like index stuff, which is a typical use case. Note that this doesn't handle crashes. It doesn't handle you trying to redeploy stuff. If this goes down, it doesn't know where it left off. It just reads through stuff. It's also not distributed. There's only one node running it, right? So there's a limit to how much throughput you can handle. So that's why we have consumer groups. So they're almost as easy to set up. You simply create a consumer object. You give it a group ID. You subscribe to one or more topics, and then you just consume messages. And any process you start up with the same group ID here will join the group, and they'll coordinate access, and they'll determine which member should have which petition. Of course, you cannot have more group members than there are petitions. So you may need to think about that when you decide how many petitions you want in your topic. But that's pretty much it. That's how you set up a Ruby consumer. There's maybe a little, you may want to have a way to send a signal and ask it to shut down gracefully and stuff. But there are examples of that in the README. It's pretty easy stuff. So Kafka as a system may be complicated. The Java API may be complicated, but it's actually really easy to get started in Ruby and in Rails. Any more questions on how to do so? Yeah?
I just wonder what the wire protocol looks like. I mean, what's being used?
So the question is, what does the wire protocol look like? Yeah, pain. It looks like pain. It's a binary protocol, and basically the client library is developed in the same code base as the broker itself. And for years, it just had the one Java one. And there's this weird system of protocol definitions that are really difficult to figure out. So it took me a while. There was some documentation, but some was lacking, some was just wrong. So I spent days trying to figure out why stuff was decoding in the wrong way until I discovered, like after reading the Java source code, that, oh, it documented it in the wrong way. So yeah, decoding a binary protocol is not fun. But I've done the hard work. The fit of rage pushed me through it, so it works now. But yeah, binary protocols can be difficult. They're also obsessed with bytes and keeping bytes a minimum, because LinkedIn wrote Kafka, and they have trillions of messages a day. So every byte they add to a payload is going to multiply, right? So it's a very space-conscious protocol. Yeah, you can go on GitHub. It's open source, nice README. Yeah, more questions? One on there?
Yeah, are there any other specific tools that you use for like instrumentation in Kafka, or like basically getting some insights in production and that kind of thing?
So yeah, the question was if there are any specific tools we use to instrument and monitor our usage of Kafka. So yeah, actually, so the goal for Ruby Kafka was not to become the fastest client on earth. Like Ruby's just not built for being really fast or good at data crunching. It doesn't have like the number crunching abilities of Python. It's not as fast as C or Java. So actually, one of the focus areas of Ruby Kafka was instrumentability. So it's very heavily instrumented, and you can monitor a bunch of different key insights. One of them, for the producer, for instance, the size of the internal buffers in the asynchronous producer is a key metric that is instrumented. The number of messages you have to reject because you have full buffers is another one. So there's a bunch of different things. How far behind a consumer is from the end of the topic. So if you start reading, like how far until it actually reaches the end, right? In our case, we have some topics where occasionally we can't actually process things fast enough, so we'll get farther and farther back in time. So there's a built-in thing that publishes data to Datadog if you have that enabled, because that's what we use internally. But it uses active support notifications. I don't know if you use that. That's the standard. Actually, that's also a pub-sub mechanism within Rails. So it uses that, so you can add another subscriber. There's logging, and if people use something like Librato or something, it should be pretty simple to add that in and subscribe to all the notifications internally and publish that stuff to Librato so you can monitor it. More questions? Yep. Yeah, so Confluence is a company that was spun out of, the question was if we've looked into using Confluence to sort of manage all this. Confluence was spun out of LinkedIn, the engineers who built Kafka. And it adds some management tools, I believe, and a schema repository for Avro, which is a different topic. I'm also interested in Avro. I don't know if you use it internally. Maybe. We have some ops. They're sitting in San Francisco. I don't know. We may have switched to it. I imagine we have. At least we have some kind of contract with them, I guess. And yeah, I would love to use Avro to basically a huge pain in the ass, especially when you store messages over time, is that your schemas are going to evolve, and how are you going to handle those changes, right? So they have one solution for that. We haven't adopted Avro, unfortunately, although I made an attempt. Oh, down there.
So are there any special considerations that you take into account when you're doing cross-language publishing and subscribing? So you've got like maybe a Rubyfuza and a JavaScript file.
Not really. Like, not unless you like encode stuff as Java objects or something, or do like Ruby Marshall. But if you encode stuff as JSON or Avro or protobufs, it's not a problem. So, I mean, you can't have a consumer group consisting of different language processes. That would be crazy. But other than that, the entire idea is actually that it decouples the producer and the consumer in such a way that you can add any language. It's completely standardized. And I believe there are some good, like, non-Ruby, non-Java libraries out there now. There's one in C and one in Python, and maybe PHP or something. And Node? Yeah, always a Node. Okay. Do you have more time, or? Okay. You can ask me more questions later. Thank you.